Welcome to
Trial
this
version.
mechatronic lecture series. Today we will see the
Trial
fourth
version.
lecture in the series of lecture in mechatronics of module 3
Trial version.
on PLC. I am Dr. B. Krishna Prabhu,
Trial
Professor
version.
of Department of Mechanical Engineering, Canara Engineering College, Mangalore.
Trial version.
In this lecture,
Trial version.
we have something on inputting the programs in the PLC
Trial version.
and their processing, input output processing,
Trial version.
mass input output copying, as well as input output
Trial version.
addressing. These are the four topics that we cover in today's lecture.
Trial version.
So first of all, coming to inputting the programs into PLC.
Trial version.
We know that PLC is very good when it
Trial
comes to
version.
processing of data, especially the input that is being
Trial
provided
version.
through the sensors. Then to process this particular
Trial
data,
version.
definitely instructions are needed. These
Trial
instructions
version.
will tell the PLC how to process the input that is coming from
Trial version.
the input devices. These instructions or a collection
Trial
of
version.
such instructions are often called as programs. So that is why
Trial version.
writing a program for PLC in order to do the
Trial
job
version.
by the PLC is very essential. Or programs
Trial
to
version.
process the input that has been coming from input devices is very
Trial version.
essential. So there are many ways by which PLCs
Trial
could
version.
be programmed, and for programming definitely we need the hardware components.
Trial version.
And programs could be entered into the
Trial
input
version.
output unit from small handheld programming device. So this is one way
Trial
of
version.
programming the PLC. We may use a small handheld device,
Trial version.
and connecting that one to the PLC, we can program,
Trial version.
we can write the program onto PLC using this handheld programming device.
Trial version.
Now in the industrial environment, many a time it is
Trial version.
possible that the PLCs that we are talking about is on the
Trial
shop
version.
floor, in the control center
Trial
of the
version.
shop. So if many such shop floors are available and
Trial
PLCs
version.
are distributed among the shop floors at different locations,
Trial
then it
version.
becomes very essential to have a handheld
Trial
programming
version.
device which could be taken from one PLC to other PLC, and
Trial version.
and the programmer can think of programming that particular PLC.
Trial version.
Otherwise, these PLCs may needed to be disconnected from there and brought to the
Trial
programming
version.
center and program it over there and reattach it to
Trial version.
the control room, which may be very tedious job. So that is why
Trial
people
version.
normally prefer a handheld device that
Trial
could
version.
program the PLC, especially when PLCs are distributed among different shops
Trial
of
version.
the industry. This is the one way of doing it. One more
Trial
method
version.
is using a desktop console with a visual display unit,
Trial
keyboard,
version.
and screen display. So this is one more way. Or we can make use of a
Trial
personal
version.
computer also for programming the computer. Like for example,
Trial
in
version.
Arduino, it is a small PLC. That is why Arduinos are often
Trial version.
programmed using a personal computer or using a desktop console.
Trial
So
version.
most of the time, handheld programming devices are not used over.
Trial
Arduino
version.
basically comes with the USB cable itself. That USB cable
Trial
could
version.
be used to connect Arduino board to a PC, and we can write
Trial
the
version.
necessary programs in IDE and
Trial
transfer
version.
that program to the Arduino board after compiling it. So that is
Trial
one more
version.
method of doing it. So there are basically two different ways by which
Trial
we
version.
can program a PLC. One is using a handheld programming
Trial
device,
version.
and other is using a desktop console or a personal computer.
Trial version. Trial version.
So,
Trial
of
version.
course, whenever we have to have a program for
Trial
PLC,
version.
first of all, it is needed to be written somewhere. So normally, like in Arduino, I said
Trial version.
IDE, Interactive Development Environment, that has been used,
Trial version.
which acts like a compiling station for writing a program.
Trial
So
version.
in IDE, we can write a program, then we can
Trial
compile that
version.
program, we can troubleshoot for errors, and after that
Trial
compile that
version.
particular program. Once it is compiled, then that program could be transferred
Trial
from a
version.
personal computer to a PLC. So once it is
Trial
transferred to the
version.
PLC, then the connection between, or USB connection between the
Trial
PLC and the
version.
PC is not needed, because the compiled program is already transferred and it is
Trial
retained
version.
in the RAM or ROM section, read-only memory section
Trial version.
of a PLC. So once that has been transferred, then there is
Trial
no
version.
further problem. But often we have to make use of
Trial version.
a programming device in order to write a
Trial
program for
version.
PLC, and then once it is ready, it is transferred to the memory unit
Trial
of
version.
PLC. The next one, coming
Trial
to
version.
input output processing, a PLC is continuously running through
Trial
its
version.
uh, program and updating it as a result of
Trial
the
version.
input signals. Now, of course, the PLC is connected to
Trial
input
version.
devices, and many a time these input devices, let us say, is a
Trial
sensor.
version.
So a sensor is continuously sensing a physical property and
Trial
sending
version.
the, say, electrical signal to the PLC.
Trial version.
Now, whenever it is sending such signals, now program is to be designed in such a way
Trial
that it
version.
continuously assesses the receiving of the input
Trial
signals
version.
from sensors. Now, once
Trial
that
version.
signal reaches the PLC, and once that is
Trial
been
version.
assessed, then that complete cycle is known as a cycle. That such a loop
Trial
is
version.
termed as a cycle. So a PLC is continuously running through its
Trial
program
version.
and updating it as a result of input signals. Input signal is
Trial
coming in,
version.
and PLC continuously updates itself when
Trial
a
version.
signal is coming in. Then, of course, that signal is been sent in order for processing, and whenever
Trial
such
version.
inputs are been coming in and assessed, it is called, that particular loop is called a
Trial
cycle.
version.
There are two
Trial
methods
version.
that can be used for input-output processing. Now, input-output processing
Trial
could be
version.
done in two different ways. So let us just see what are these two different
Trial
ways,
version.
and how these two different ways, how these two ways
Trial
are
version.
different from each other, right? So first method is
Trial
continuous
version.
updating. Second one is mass input-output copying. Now the input is
Trial version.
continuously coming from the sensor, and updation
Trial
of
version.
the PLC with respect to the input that is coming. If it is done
Trial version.
continuously, then it's called continuous updating, right? So
Trial
if we
version.
have something like say 1000 sensors that are being connected to
Trial version.
a PLC, then first sensor is
Trial
sending a
version.
input, then the PLC will first of all engage itself to that
Trial
particular
version.
signal that is coming in, and then it finishes off that one cycle
Trial version.
with that particular sensor. Now then it goes to the second sensor,
Trial
and
version.
second sensor is sending some input, and that particular input is identified by
Trial
the
version.
PLC, and one more cycle is being sent. But note that whenever this is happening, whenever
Trial version.
PLC is working on one of the sensor, then the rest of the sensors,
Trial version.
999 sensors, they are idle. Whatever input that
Trial
are being
version.
sent by those 999 sensors are not being
Trial version.
accessed by the PLC. That is one big problem with this one. Let us
Trial
see
version.
some more details about continuous updating.
Trial
CPU
version.
scanning the input channels as they occur in
Trial
program
version.
instruction. So in the program we are writing that we have to access the
Trial
signal
version.
sent by the sensors, and based on the way in
Trial
which the
version.
program is being written, CPU scans the input.
Trial version.
Each input point is examined individually.
Trial version.
See, that is what I mentioned. If a first sensor is sending the signal,
Trial version.
and if CPU has engaged itself with that particular
Trial
sensor,
version.
what about the other 999 sensors? That is what the major question.
Trial
And
version.
its effect on the program is determined. Now this first
Trial version.
sensor has sent some input. Now using that input,
Trial version.
what is to be done? Processing of that particular input is to be done.
Trial
Now
version.
whenever we do that one, then there is a built-in delay. That built-in delay is
Trial
because
version.
it has that sensor signal has to come from the sensor to here, then it
Trial
needed to be
version.
processed, then CPU or PLC wants to make
Trial
sure
version.
that the input that has come from the sensor is very genuine
Trial
and
version.
it is good for processing. That takes a certain amount of time, something like 3 milliseconds.
Trial version.
So that particular 3 millisecond is known as built-in delay.
Trial version.
For that 3 milliseconds, no other job is being done. That is what
Trial version.
delay basically means. Right? So if just
Trial
imagine
version.
that if the first sensor is spending something like 3 milliseconds,
Trial version.
then 1000 sensors, in order to access
Trial version.
first sensor to 1000 sensor, we need 3000 milliseconds. 3000 milliseconds will come to somewhere around 3
Trial version.
seconds. So for accessing 1000 sensor, it needs around
Trial
3
version.
seconds of delay. Then each input is examined
Trial
in
version.
order to ensure that only valid input signal are read by the
Trial version.
microcontroller. So validation of the input is needed to be done, for
Trial
which
version.
3 milliseconds is gone. Then the time required for processing that particular
Trial
signal,
version.
that is extra. Right? So that is why, as I mentioned, when
Trial version.
first one or two sensors are being examined,
Trial
the
version.
examination of other sensors are not taking place, and in that particular
Trial
time period
version.
of 3 seconds or something, if anything goes wrong in any other
Trial
part
version.
of the plant, and the sensor connected to that one, if it is
Trial
sending
version.
the signal to PLC is not going to visualize that
Trial
particular
version.
signal, because it is continuous updating.
Trial version. Trial version.
So again, that particular
Trial version.
delay, make sure that the microprocessor
Trial version.
avoids counting an input signal twice or more
Trial
frequent,
version.
right? More frequent. So many a time more frequent visualization
Trial
of the
version.
signal is essential.
Trial version.
Based on the seriousness of the
Trial version.
feedback that is been coming from the sensors.
Trial version. Trial
Because
version.
there has to be 3 milliseconds delay on each input, the time taken
Trial
to
version.
examine several hundred input output points can become
Trial version.
comparatively long. It may become comparatively long. I gave you the
Trial
example of 1000 sensors and the amount of delay
Trial
that has
version.
been encountered over there, something like 3 seconds. But
Trial
an
version.
industry often has thousands of sensors that are being connected at
Trial
different
version.
locations. So that is why this delay really creates problem
Trial
whenever
version.
we have continuous updating. But if continuous updating is been done, that
Trial
particular
version.
delay is very essential, so that microprocessor
Trial
validates
version.
the kind of signal that is coming in and make sure that the
Trial version.
input is not been, or the signal that is being sent by the sensor is
Trial
not
version.
been counted second or third time.
Trial version.
So then alternative for this continuous updation is a
Trial
mass
version.
input output copying. So this is an alternative to previous one.
Trial version.
Whatever disadvantage that we have over there in the first case,
Trial
continuous
version.
updation is been eliminated in mass input output copying. So as you can
Trial version.
see, it is a copying of a input or output signal in mass.
Trial version.
Like for example, if we are having 1000 sensors,
Trial
all these
version.
sensors are accessed simultaneously. In first instance,
Trial
all
version.
these 1000 signals that are being sent by 1000
Trial
sensors
version.
are being taken by the PLC,
Trial
and
version.
PLC retains it in its RAM. So
Trial
that is why
version.
a small buffer area is required in the RAM, so
Trial
that
version.
these input signals are retained or kept over there for
Trial
further
version.
processing to allow more and rapid execution of the program. See,
Trial
first thing,
version.
rapid execution of the program. Rapid execution of the
Trial
program is
version.
possible with the mass input-output copying. A specific
Trial
area
version.
of RAM is used as a buffer store between the control logic and the input-output
Trial
unit.
version.
So a small buffer in the RAM is been dedicated
Trial version.
only to retain the inputs that are coming from the
Trial
sensors.
version.
Only to retain the input outputs that are required to be
Trial
processed
version.
by the PLCs. Now note that in the first instance itself, all the
Trial version.
1000 inputs are coming. Whereas in the previous case, in one instance, first
Trial version.
sensor is sending the data. Second instance, second sensor is sending the data.
Trial
So for
version.
1000 sensors, 1000 instances are required.
Trial
And that
version.
also involves 3 milliseconds of delay every time.
Trial version.
Whereas over here, all that 1000 signals are received by the
Trial
PLC
version.
in one instance, and that is retained in the RAM.
Trial version.
And immediately with the very high speed, all these
Trial version.
inputs are being assessed and processed by the arithmetic
Trial
logic
version.
of the PLC, right?
Trial version.
Each input output has an address in the memory. So here the
Trial
way
version.
by which it is stored in the memory, that is being explained. Each input,
Trial
because
version.
every input is very useful. It should be
Trial version.
distinguishable from other inputs. That is why every input must have its
Trial
own
version.
unique address, right? So that address is given, and
Trial
with that
version.
address, this input is being stored.
Trial version.
At the start of each program cycle, the CPU scans
Trial
all
version.
the inputs and copies their status into the input-output address
Trial
in the
version.
RAM. In one instance, all the inputs are being
Trial
accessed
version.
by the or scanned by the CPU. As the program is
Trial version.
executed, the stored input data is read and
Trial
required
version.
from the RAM, right? As and when these inputs are required as
Trial
defined
version.
in the program, then one by one this data is being taken
Trial
in,
version.
they are processed, and output is produced, right? That is how this mass
Trial
input
version.
output copying processor works. The resulting output signal are stored
Trial
in the
version.
reserved input output section of the RAM itself, and later whenever they are needed, they
Trial
are
version.
used. At the end of each program cycle, all the outputs are transferred
Trial
from RAM
version.
to the output channel. So when 1000 inputs are been
Trial version.
inputs are been scanned and processed, that processing will
Trial
give the
version.
output, and all those outputs are been kept in a reserved location in the RAM.
Trial
Once
version.
one complete program cycle is over,
Trial
then
version.
the output that is been stored in the RAM, buffer of the RAM,
Trial
that is been
version.
transferred to the output channel, and that output is utilized basically for
Trial version.
utilized for doing actuation job. The
Trial
outputs
version.
are latched so that they retain their status until the
Trial
next
version.
update. Right? So once this cycle is over, then the second cycle starts
Trial
with the
version.
inputs coming from the sensors. Then again, it is being scanned,
Trial version.
processed, output is produced. When all the outputs from all the sensors are being ready,
Trial version.
then it is transferred to the output channel. Then the third cycle starts.
Trial
That is
version.
how cycle by cycle, using mass input-output copying, the
Trial version.
processing of the input is being done by the
Trial
PS.
version.
Next,
Trial version.
input-output address. The PLC has to be able to
Trial
identify
version.
each particular input and output, and it does this
Trial
by
version.
assigning address to each, rather than like
Trial
houses
version.
in a town have address to enable post to be delivered
Trial
to the
version.
right families. Now this is one peculiar example we
Trial
often
version.
give about distributing the post to different
Trial version.
houses in a locality, and we compare that one to
Trial version.
addressing that has been done by the computer. So often we use this
Trial version.
example, right? So 1000 sensors sending the input,
Trial
all
version.
those inputs are very essential, hence they needed to be identified
Trial
very
version.
clearly. To identify them very clearly, and
Trial version.
to isolate one input from the other input, each and every
Trial version.
input or each and every output that is produced is being addressed.
Trial version.
And all and every address that is been provided is very unique. That
Trial
is why
version.
there is no confusion between two signals, because they are
Trial
having
version.
unique address. With a
Trial
small
version.
PLC, the addresses are like to be just a number
Trial
preceded by
version.
a letter. So number and a letter, right? While talking about
Trial
PLC
version.
programming, we have seen this particular aspect, something like
Trial version.
X401. So that actually is a address. So individually,
Trial version.
if it is X401, the next address will be X402,
Trial
and the
version.
first and second one are easily distinguishable from each other, and
Trial
every
version.
such address carries one signal that is being coming from the sensor, or
Trial
one
version.
output that is produced by the PLC, intermediate output, right?
Trial version.
Yeah. Now either we
Trial
can give
version.
X or we can give A. So basically, these letters will distinguish whether
Trial version.
the address that we are talking about is input address or output address.
Trial
Right?
version.
So for example, yes, here you have the example. Mitsubishi and Toshiba
Trial
have
version.
inputs identified as X400, X401, X402,
Trial
etc.
version.
This is a X letter is representing by
Trial version.
international standards, it is a input. If we have Y, it means that it is a
Trial
output.
version.
Output, like address could be something like Y430,
Trial version.
Y431, etc., etc. So input and output could be easily distinguishable
Trial
from
version.
each other. With larger PLC having several racks of inputs
Trial
and
version.
output channels and a number of modules in each rack, the
Trial
racks
version.
and modules are numbered. Rack and modules are numbered. This is very much similar
Trial
to
version.
how the the sector addressing is being done in a hard
Trial
disk.
version.
So the sectors are present in a cylinder. So
Trial
cylinder
version.
and sector number together will give the address of any
Trial
location
version.
in the hard disk. That is how it works. Very much similar
Trial
pattern is
version.
been followed even in a PLC. So if you have rack and then modules,
Trial
rack
version.
number and module number will constitute the address of any location that we are
Trial
talking
version.
about, are numbered. And so an input or output is identified
Trial
by
version.
its rack number followed by the number of the module
Trial version.
in the rack, and then a number to show its terminal
Trial
number
version.
in the module. So first of all, a rack number, if there are 10 racks, and if
Trial version.
a number that I'm talking about is stored in say third rack,
Trial
so
version.
first number will carry 3 apart from X and Y. So first
Trial
number is
version.
3. Then in that particular rack, if there are say
Trial
100
version.
modules, in which module it is being present. So let us say that it is
Trial
something
version.
like it is something like 9th module. So next number
Trial
that is going
version.
to come is a 9. So rack number followed by module number.
Trial version.
For example, in a Allen
Trial
Bradley
version.
PLC5 has, see, this is how it is represented. I colon
Trial version.
012 slash 03. So 012 slash 03.
Trial version.
This indicates that input is in the rack 01, that is first
Trial
number
version.
01. At module 2, that is module number 2.
Trial
And
version.
in the module, the terminal is 3. So 01, that is
Trial
rack
version.
number, 2 is module number, and 03 is the terminal of that particular
Trial version.
rack where this data is to be stored or data is to be accessed from.
Trial version.
So that is what we have in today's
Trial version.
session. So we could able to understand little bit on how exactly the
Trial
programming
version.
could be done or stored in PLC, and
Trial
something
version.
about input output accessing as well, right? So
Trial
thank
version.
you very much for joining. See you again with one more topic on
Trial version.
mechatronics module number 3.
Trial version.